Hello, class. We're going to be talking about solving quadratic equations in this video. And so I think it behooves us to talk about what a quadratic equation is, how to identify it, and then how do we go about processing it so that we can actually find the solutions. Okay, so in the lecture notes, you will see some slides that describe what a quadratic equation is, but we got some more vocabulary that we have to get down. How do we identify a quadratic equation? What is it? So a quadratic equation in one variable is considered a second degree polynomial equation of the form ax squared plus bx plus c equals 0. Okay. This is called the standard form of an equation when it is set equal to 0. And specifically for a quadratic equation, you're looking for, at the very least, this one of the terms being x squared. Okay, that's what we mean by second degree polynomial because the degree of the polynomial refers to the highest exponent that you observe when you see the equation in standard form. And we can see that the highest exponent on the variable x here is a 2. Okay, so that's where we get second degree from. Okay, another way that you can identify whether or not you're dealing with a quadratic equation is if you remember a little bit of etymology. The word quadratic comes from the Latin quadratus, which for many students that are in the Alamo College district are bilingual or at least exposed to Spanish. So, like I said, quadratic comes from quadratus, which is Latin, but the closest term that you could get to that in Spanish would be cuadrado, which means squared. Okay, so if your highest exponent is a 2, that means that you have a squared term. Okay, so a quadratic equation is going to have a squared term, whereas if we were to omit this term ax squared, then you would be back to something that looks more like a linear equation, where you just have x to the 1 power. Okay, now setting that aside, what do we need to do when we find that we're dealing with a quadratic equation? Okay, so the first thing that we might have to do is ask ourselves, is this in standard form? Okay, and then it really depends on the type of quadratic equation that you're dealing with. Okay, so we're going to look at a few different techniques for solving quadratic equations. And this first video on solving quadratics is really going to deal with using something called the zero product property. Other words, using factoring to solve quadratic equations. So let's take a look at this example here and see how we go about dealing with it. Okay, so let's jump over just to pencil and paper so that we can make sense of this. Okay, so let's say that you encounter one of these problems in the homework, solve the quadratic equation. Here we have 2x squared minus 5x equals 12. Okay, what you should know as we're learning to deal with these quadratic equations is that the standard form, so standard form, should be ax squared plus bx plus c equals 0. That equation needs to be set equal to 0. Otherwise, we can't start processing this equation. Okay. So if we see this one that we're dealing with, 2x squared minus 5x equals 12, you might say to yourself, well, we have that 12 on the right-hand side of the equal sign, and we need to move that over to the left so that we have all of the terms on the left side and we just have a 0 on the right-hand side. So the way we can cancel out this 12 is simply by subtracting it over here. And then this might seem a little bit confusing. I'm just going to put the negative 12 right here on this side. Because remember, anything we do to one side, we have to do to the other side. If I subtracted 12 here, I need to subtract 12 there. But I want you to know that I'm not putting the minus 12 underneath the 5x because I can actually subtract that. These are not like terms. Okay, so just be aware you should not be subtracting negative 5x minus 12 because we shouldn't be able to do that. Okay, but 12 minus 12 certainly is 0 equals. On the left-hand side, we're instead just going to write this equation out as 2x squared minus 5x, and now we have a minus 12. So that now we have 1, 2, 3 terms on the left. We have our squared term, we have our x term, and then we have our constant, okay? And those are set equal to 0. So now we know this is in standard form, okay? So that's going to be the first step. Uh, get your equation in standard form. Okay. And then it might not seem obvious what we need to do next. But in the previous videos that we looked at, we were learning how to process and solve, or rather factor polynomial expressions. We dealt with things that had a greatest common factor, things that had 4 terms, and we could factor by grouping. We learned about the AC method, and then we learned about the difference of squares binomials that we could process using a special formula, okay? Well, over here on the left-hand side of the equation, we are dealing with a trinomial. You might call this a quadratic trinomial because we have this x squared, but in any case, it is a trinomial, okay? So if we remember that we're dealing with a trinomial, then it might be very useful to factor this trinomial. So the next step is going to be factor the trinomial. And you might recognize that that trinomial is of the form ax squared plus bx plus c. Okay, and the reason why we label our quadratic equation in standard form this way is because we need the a and the c to start the AC method. Okay, so right off the bat, we can go ahead and label our coefficients a, b, and c. So here I have coefficient a, and at -12, I have coefficient C. We'll deal with coefficient B later, as we have seen in previous videos. But for now, we're going to take 2 and multiply it by 12. Okay, so we have A times C is equal to 2 times -12, which gives us -24. Okay, we're going to find all of the factor pairs of 24. What are all the pairs of numbers that multiply and make 24? That's 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work, and then we're back at 6. And we need to pick the factor pair that meets those 2 conditions that we were talking about in the previous video. That is, they need to multiply to give us the -24 here. So since this is negative, we know that one of those factors needs to be a negative, okay, when we choose the pair. But we also need the pair of factors that's going to add to give us the b term, which in this case is -5 for this problem, okay? So we might start off by asking ourselves, which of these pairs of numbers can we add or subtract to get a 5 or a -5? Well, that's going to be 3 and 8, okay? And the only way we're going to get a -5 is if we make the 8, the bigger number, the negative, and we keep the 3 as a positive. So if I have 3 plus -8, that should give me my -5. And then likewise, 3 times -8 gives me the -4. So I've met my 2 conditions there. And those are the only factor pairs that are going to work. Okay. So we can go back to our polynomial. We have that trinomial. We're going to break up the middle term, as we saw in the past, into 2 terms. And we're going to use these factor pairs to do it. So instead of -5x, we're going to write down plus 3x minus 8x, since if we were to combine these terms, they would give us back that -5x, okay? If they don't, then we made a mistake in our choice of either the signs on the factor pair or we chose the incorrect factor pair. These need to combine to make that middle term -5x, okay? And if they do, we can go ahead and proceed by bringing the 2x squared down, and we can bring the -12 down so that we now have a 4-term polynomial. Guess what, guys? We're going to go ahead and factor by grouping now. So if I look at these two terms, 2 and 3, there's nothing that divides them evenly except for 1. So since they both have an x, I'm going to factor out an x. And then you could sort of push this forward and think about it as the distributor property. In the past video, I said divide out the x, but what I really like to do is just do x times what gives you 2x squared. I'm missing a 2x there. So that x times 2x gives me the 2x squared back. You can also do x times what gives you 3x. Well, we're missing a plus 3. Okay. And that's the same as dividing out that x. It's just a different way of looking at it. We'll look at the next two terms here, -8 and -12. What is the number that divides into 8 and 12? 2 works. 4 is even better because it's a larger number and we're looking for the greatest common factor. And 4 is actually going to work. So since this first term is a negative, we need to bring that negative down and factor out a -4, okay? So then we can play that game of the distributor property. -4 times what gives you -8x, and that's going to be 2x, right? -4 times 2 is the -8. That worked. And then we needed an x to get that x back. Then we can think about -4 times what gives us a -12. Well, we're going to need a positive number there, and it's -4 times 3 that's going to work. Okay. So if that makes sense, and if these guys in parentheses match, then that tells you that we have 2x plus 3 as our first factor, and then we have x minus 4 as our second factor. Okay. So up until this point, I have sort of neglected the fact that we had this equals 0 on the other side of the equal sign. That is going to be something that's very important. So I'm going to bring that back in here, equals 0, because we're still dealing with this equation, and we still want to have our quadratic equation in standard form, even though it's now factored. Okay, so this part should have been a review, right? We get our quadratic trinomial in standard form, then we apply the AC method, factoring by grouping, and we factor that quadratic equation, okay? Now, the reason why we're doing this, and the reason why factoring is so useful for solving certain kinds of equations, is because we can now apply something called the zero product property. Zero product property. And so the zero product property is a very simple piece of logic that should make sense when we're just dealing with a couple of numbers. So take a pause right now and think about this scenario. Let's pretend we're not dealing with this quadratic at the moment, and we want to think about this zero product property. Let's say that we had a number A. I don't know what that number is, but we're going to multiply it by a number B. Again, I don't know what that number is. Okay, we have two numbers multiplied by each other, and we get 0. Think about this for a moment. Let's say that I don't know what A is, but B could be anything. I multiply these two numbers and I get 0. What is a possible value for A? Okay, just think about that. Something times something else, and I get 0. What is the first thing? What's a possible value? Well, first scenario here is that A could be equal to 0, right? Because regardless of what B is, if A was 0, then 0 times B, 0 times B would be equal to 0, and we would get that true statement. So it's possible that A is equal to 0. But there's a second scenario here, and that is, let's assume that A could be anything, right? Any non-zero number. You multiply it by B, and you get as your product 0. Well, that means that B would have to be 0, right? Because the only way you're going to get two numbers to multiply to make 0 is that one of them has to be 0. Either A is equal to 0 or B is equal to 0, such that A times 0 equals 0. That should make sense. There is a third option. The third option is A and B are both equal to 0, since it should make sense that 0 times 0 is equal to 0. Okay, that's kind of an obvious situation. Okay, So that's what the zero product property is saying. It's basically saying you have two things. They could be numbers or they could be algebraic expressions or polynomials. But if you multiply two things together and get zero, then one of those things or both are equal to zero. Okay. So let that sink in. And then we're going back to our quadratic equation. If you think about it, this first polynomial, this first factor that we have, is being multiplied by this second factor. So we have two things that are being multiplied. Okay. We don't know right now what 2x plus 3 is. Doesn't matter. We could just call that a if we wanted to in this situation, just as a placeholder. Something times this other factor equals 0. So it's possible that we have 2x plus 3. Whatever that is, it could be 0 since it's being multiplied by something and then we're getting 0. That's one possibility. Okay. The other possibility is that x minus 4, the other factor, is equal to 0. Okay. But the only way you're going to multiply two factors together to get 0 is that one or the other is equal to 0, or the third option, which is possibly both of them are equal to 0. In any case, if we set each of these factors individually equal to 0, they're no longer a quadratic equation. Now we have two linear equations, and we can just solve them individually to find the value of x. Okay? So if we sort of cover up one of those factors or one of those linear equations with our hand and just focus on this first one, we should be able to solve this for x, right? We have a plus 3 here, which we could cancel out simply by subtracting it over to the other side. So if I subtract 3 here, subtract 3 here, I should get 2x is equal to negative 3. And then we can finish the job here by dividing out the 2, such that now we have x is equal to negative 3 over 2. It turns out that this is one of your solutions for that quadratic equation. Okay. And then if we look at x minus 4 and try to solve this linear equation, we would just have to add 4 over to the other side, such that we now have x equals positive 4. And then we have another solution. Okay. So it turns out that these quadratic equations will yield two solutions, right? And one thing that might sort of lead you in the right direction here or lead you into realizing that we need two solutions for any quadratic equation is that these are called second degree polynomial equations. And the degree of the polynomial tells you the number of solutions we should obtain when we solve the equation. So since the quadratic equation has that highest power of a 2, right away we should have understood that we are going to get two solutions for these. So unlike linear equations, we should be getting two solutions in most cases. Okay. So if you need to go back and rewind and watch this part, this little example equation, just so you can get the process down, please do so. But we will take a look at some other examples just so that we can get the handle on this, okay? So let's get back to the slides. All right. So if you go through the notes that are in Module 2, then we should see that there are going to be three primary methods for solving quadratics. And the first one that we're learning here in this video is solving quadratic equations by factoring and using the zero product property. In the next video, I'll show you guys how to solve quadratic equations by using the square root property and then something called the quadratic formula. Okay, but for now, we're still focusing on factoring and applying this newly acquired zero product property. Okay, so we looked at this quadratic equation, and to quickly recap, we needed to get it in standard form and then factor the quadratic polynomial. So we subtracted the 12 from the right-hand side of the equation over to the left, such that we now have our quadratic equation set equal to 0. That's going to be very important. For any quadratic that can be solved by factoring, you have to get it into standard form first. Otherwise, you will not be able to properly apply the AC method or your factoring methods. It must be set equal to 0. Okay, but once we get that set equal to 0, if we have three terms on the left-hand side, we can apply the AC method, which in this case we took 2 times -12, multiplied that out, and then found all of the factor pairs of that product. Okay, so we took 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then we said, okay, which of these factor pairs is going to get me to a 5? In this case, a -5, since that's the value of b. We chose correctly here, and we found that plus 3x and minus 8x was going to work. Okay, so we went ahead and factored by grouping and got our two factors. Once we did that, we applied the zero product property, and then we went ahead and set each of those two factors set equal to 0 so that we have two linear equations that we could solve using the techniques that we learned in Module 1, or sort of refreshed for Module 1. Okay, so we got our two solutions there, -3/2 and 4. Okay, so we have a few other practice problems that we can go through. I think I'm going to jump in and maybe do a couple of these for you, just so that we don't drag this out too much. So let me write this down. The first example, A, is going to be 6x squared plus 11x equals 10. Okay. So let's go ahead and jump over to the document camera, and then we can get started. Okay, so we have our quadratic equation here. We can identify that it is a quadratic equation by noticing that the highest power is a 2. So there's our highest power, which we know that means that this is a second degree equation, and that also means that we're going to have two solutions when we get to the bottom of this. Okay. But remember, the first step of solving a quadratic equation is that it must be in standard form if we're going to be able to factor it and then apply the zero product property. Okay, so right away, I can see that I have an equals 10 over here on the right-hand side. I'm going to go ahead and subtract that 10 to move it over to the left-hand side of the equation. Just being mindful that I'm not actually going to do 11x minus 10. Instead, I'm just going to rewrite this as 6x squared plus 11x minus 10 equals 0 now. So we do have that in standard form, and we're good to go for the next step. Okay, so the next step is just to apply the AC method. And the reason we can apply the AC method is because we have 1, 2, 3 terms for that polynomial on the left-hand side. So we're going to do 6 times -10, and that's going to be -60. Okay, we can figure out what all the factors of 60 are: 1 and 60, 2 and 30, 3 and 20. Don't know if 4 works, but you can always grab your trusty calculator and double check that. So 60 divided by 4, 4 and 15. 60 divided by 5 is 5 and 12. That's going to be 6 and 10. I don't think 7 will work, but we'll just be thorough. 7 didn't work. And I'm pretty sure that 8 won't work. 60 divided by 8. 60 divided by 9. And then we're back at 10. So we have everything we need here as far as our factors are concerned. Now, we're looking for the factor pair here that will either add or subtract to give us 11, since that's the value of b. Okay, so looking at these numbers, we might say to ourselves, well, what's going to give us 11 here? It looks to me like 4 and 15 are the only numbers here that are going to get us close to an 11. Okay. And so we need to remind ourselves, okay, we need to get two of those factors. They need to multiply to give us negative 60, which means one of them needs to be positive and one of them needs to be negative. So we're going to have something plus something else, and that needs to give us a positive 11. So since we need to get a positive sum when we add them together, that means that if 4 and 15 are going to work, then it's going to have to be a negative 4 and a positive 15 so that when I add these together, I stay positive. And that's going to work out here. So negative 4 and positive 15 add to make that 11. Negative 4 times positive 15 multiply to give you negative 60. So that works out. And that's the only factor pair that's going to work. Remember, if you got those signs backwards, then we wouldn't have met these conditions, since if I had switched those signs and had a negative 15 and a positive 4, that would have been a negative 11. Okay, so we need both of those conditions to work before we can move on. But once we've gotten that correct, we'll break up the middle term so that we now have negative 4x and positive 15x. Then we can bring down the negative 10 and the 6x squared so that we have 4 terms in this polynomial. Okay. Now it's just downhill from there because we're using the factoring by grouping. So these two terms, what's a number that divides into 6 and 4 evenly? Well, that's going to be a 2. But they both have an x, so I'm going to factor out a 2x. Okay. So if I factor out 2x, 2x times 3x will give me the 6x squared back. 2x times negative 2x will give me the negative 4x. So if I've done that correctly, when I go over here and factor out my GCF, I should be getting that same expression in, actually, I've made a mistake here, because if I had 2x times negative 2x, this would be negative 4x squared. So that tells me that I did not need this x here. It should just be minus 2, okay? But if I factor out the GCF of the next two terms, I should be getting the 3x minus 2. And if I don't, then I've made yet another mistake. So there are ways to catch yourself as you're going through this. So just make sure you're taking your time and getting that accuracy before you start working on speed. So 15 and 10, a number that divides into them evenly, is 5. So we're going to try to factor out a 5. So we'll go with positive 5, open up some parentheses, and then see what it's going to take to get us that 15x back. Well, that's going to be a 3x. 5 times 3x is 15x, and then 5 times negative 2 gives us that negative 10. So now we do have the same stuff in the parentheses, which means we're good to go. So our factors for this quadratic equation are 3x minus 2 and 2x plus 5. 2x plus 5 equal 0, okay? Because we're solving an equation. We're not just simply factoring and ending it there. We need to go all the way here. So we got this thing in standard form. We applied our factoring method, and now we can go ahead and apply the zero product property, which you could just succinctly summarize as splitting this up into two linear equations and then solving those individually. So we're going to go with 3x minus 2 equals 0, or 2x plus 5 equals 0, okay? Because again, the zero product property says if we have two things equal that are multiplied and they equal 0, that either one of those things is equal to 0, or the other thing is equal to 0, or possibly both of them are equal to 0, okay? So knowing that, we should be able to solve for x, since we know that one of these factors as a whole must equal 0, okay? So now we can solve for x simply by adding 2 to both sides of this equation. Then we'll get 3x is equal to 2. Divide the 3. And now that we have x by itself, 2/3 is one of your solutions. Okay. Uh, then we can go over here and say, oh, let's subtract 5 from both sides. Cancel out that 5. We have 2x is equal to negative 5. Divide the 2, divide the 2. And now we have x is equal to negative 5 over 2, which is your second solution. Okay. So we have our two solutions. What you'll notice when you're doing your homework is that sometimes the answer needs to be written in what they call a solution set. So as a solution set, we're just going to include enclosed in these braces just the numbers that you obtained here. And it doesn't matter what order you put them in, but I'm going to just put 2/3, comma, negative 5 over 2. So when your homework platform asks you enter the solution set, you don't have to put x equals. You're just going to put your first solution, comma, your second solution, and then check your answer and you should be okay. Okay. So take a moment if you need to sort of look at the grand scheme of this. We basically did the same three major steps, which is make sure your equation's in a standard form, apply the AC method or whatever your factoring method is. Once you have your factors set equal to 0, you're going to separate those into two linear equations, solve them for x, and then those should be your two solutions. So let's do another example from the PowerPoint. If you look at, let's jump to question number D. Okay. So question D on this particular slide says 24x squared minus 4x minus 4 equals 0. And this one's already in standard form. Okay. It's already set equal to 0. We have our trinomial over here. So since it's already in standard form, we can jump right into the AC method, or at least we think we might want to jump right into the AC method. But it turns out that if you can simplify this by factoring out a GCF, it's going to make your life a lot easier. It's going to make those numbers a lot smaller and more manageable to deal with. So you always, whenever you have a quadratic trinomial, you want to check to see if there's a common factor that you can factor out. So if I look at 24, -4, and -4 here, what I actually want to do here is factor out the GCF, which in this case would just be a 4. So let's factor out a 4. And if I divide that 4 out, then 4 times 6, x squared would give us the 24x squared back. 4 times negative x would give us the negative 4x. And then 4 times -1 would give us the -4 back. Okay, so all that's equal to 0 now. Okay. So as we saw in the previous video when we were learning about the AC method or different factoring methods, you always want to check and factor out the GCF before you begin. It's going to make your life a lot easier because now if we go to the next step of applying the AC method to sort of simplify this trinomial and factor it, then 6 times -1 going to be way smaller of a number compared to 24 times -4. Okay. So we always want to kind of reduce that polynomial by factoring out our GCF so that the numbers are easier to work with. So A times C is going to be 6 times -1, which is -6. And 6 only has the following factors: 1 times 6, 2 times 3. Okay. So we can say, well, we need to meet those two conditions. These factors need to multiply to make the -6. That tells me that one of those factors needs to be negative if we're going to multiply to get a negative. And then also we need to add those factors to get a -1 since that's the coefficient that we're looking for here. So we're trying to get a -1. The only factor pair that's going to work is 2 and 3. And since we're trying to add to get a -1, that -3, the bigger number is going to have to be the negative. So we're going to go with -3 plus 2 gives us -1, and -3 times 2 does in fact give you the -6. So those are the factor pairs that are going to work here. We'll go to our middle term, the -x, and we'll break that up. Okay, so we're going to break that up into +2x from here and negative 3x from here, minus 1, and then bring down the 6x squared. Okay, so we're breaking this trinomial in parentheses up into the four terms, and we're kind of holding off on this additional factor 4. We'll bring it back later if it's going to be required or if it's going to be useful. Um, but you'll actually see in a moment that it won't be. So if we go ahead and proceed with the factoring by grouping, these two guys have a 2 in common and an x in common. So we're factoring out that 2x, and it should leave us with a 3x and a plus 1, since 2x times 1 will give us the 2x back. Then this first term is a negative, so we're going to factor out a negative. But on the face of it, it doesn't seem like 3x minus 1 have a common factor. However, there is a number that divides into any numbers, any pair of numbers, and that's going to be 1. Okay, so it's usually not super useful to factor out a 1, but in this case it will be. Because if we factor out a negative 1, and we tell ourselves, well, negative 1 times 3x gives you the negative 3x, and negative 1 times positive 1 gives you the negative 1 back. Well, we just matched the stuff that we needed to inside the parentheses. So that means that our first factor is 3x plus 1, and our second factor is 2x minus 1. You can set that equal to 0, and if you want to, you can bring in the 4 here. Okay. Now, earlier I said that that 4 is not going to be super useful, and the reason is that as we go ahead and apply the 0 product property, when we first introduced this idea, we said, well, if we had two numbers, a times b, and we multiplied those together, okay, whatever those happen to be, and if we got a 0, then one or the other has to be 0. But if you think about this, we know the value of 4, right? It is a coefficient or it's a constant here. It doesn't have a variable attached to it, but we're multiplying it by this polynomial, which is variable because of the variable x here. So this could change, and this could possibly be 0 once we introduce a number for x. It's possible to get a 0 from this guy. Okay. It's not possible to change that 4 into a 0. Okay. So like if we're thinking about, we have these two variable expressions that their value is going to be changing depending on what the value of x is, it's possible that either of those could be 0. But the value of 4 is not going to change. So if you think about, oh, I have two things that are multiplying together and I'm getting 0, if we were to have introduced a 4 into the 0 product property there, or any kind of constant, it's not going to make a difference here. 4 times something. Well, either A or B is equal to 0, or both. And the value of 4 is never going to change here. So we don't really have to worry about it. It doesn't make sense to set 4 equal to 0 because it's simply never going to be equal to 0. So by that logic, we can sort of ignore that constant if we have it. We don't want to ignore any variable expressions or any polynomials that have the variable x. So that's why we're just going to focus on setting these guys, 3x plus 1 equal to 0 and 2x minus 1 equal to 0. And then we're going to do the same stuff that we saw with the last two examples. So we'll subtract 1 over here to cancel that out. Now we have 3x is equal to negative 1. Divide by 3, and we finish the job. X is equal to negative 1/3. That's going to be your first solution. Then we could add 1 over here, cancel out that negative 1. We'll have 2x is equal to positive 1, then divide the 2, and x is equal to 1/2. Okay? So we have our two solutions. If we want to write this as a solution set, then sure enough, we can go ahead and say our solution set enclosed in these braces is just going to be negative 1/3, comma, 1/2. Okay, so that's one other way of expressing your solution set. Remember, in the homework platform, it's usually not going to ask you to write it in terms of x equals. It just wants those solutions listed in those braces. Okay. So there are some other scenarios that you guys might run into that you should be aware of. So we looked at some of these practice problems in the PowerPoint, and there's some more practice problems here. If you want to take a look at them, you could go to Math World and see if uh, you can solve these on your own and get one of the tutors to check you on them. Okay. But you should be aware that the zero product property is very useful. Not every quadratic polynomial is going to be presented where you have to factor using the AC method. So for example, if we look at this first polynomial here, 5x squared minus 10x equals 0. We only have two terms in that polynomial. Let me go ahead and write this down so we can see how this is going to play out. So let's say we have 5x squared minus 10x equal to 0. Okay. Well, if we're dealing with this situation, you might notice that our equation doesn't exactly look like it's in standard form, right? Because standard form, as we've learned it up to this point, should be ax squared, which, sure, we have our ax squared term, plus sometimes minus bx, which we have our x term there, plus c equal to 0. So this constant is usually at the end before we have the equal 0. That's not the situation we have. We're missing this plus c term. But that's okay, okay? Because the zero product property is pretty flexible. So long as you can factor your quadratic polynomial, whether it has two terms or whether it has three terms, you should be able to factor it and then set your two factors equal to 0. So if we take a look at this one, if I only have two terms in my polynomial, then I have to go back into my arsenal of factoring techniques. I know the AC method is already out the window, but we might say, okay, well, do I have a greatest common factor that will divide into both of these terms? And right away you might say, okay, well, let's try that. Let's see about 5x. See if we can take that out since we're dealing with a 5 and a 10. Okay. Well, 5x times x will give you the x squared back. 5x times negative 2 will give you the negative 10x back. If we set this equal to 0, you have to realize, well, one, that this thing is still factorable. So we factored out the GCF instead of using the AC method. Okay. But now you have to realize, like, we still have two factors, 5x and the minus 2x, that are being multiplied by each other. This is 5x times x minus 2. And both of these things are variable, right? Because we have the variable x attached to them. So if we have two things being multiplied by each other that are variable, it means that it's possible that for some values of x, one or both of those things could be equal to 0. And that allows us to use the zero product property that I'm going to abbreviate as ZPP here, okay? So since I can use the zero product property, that means that, well, maybe we can just set 5x equal to 0 and see about solving that one, right? Just set the first factor equal to 0. Then we can take a look at this second factor, x minus 2, and set that equal to 0. So even though it's kind of simpler than the last three examples that we looked at, we're really still using the same process. Okay, so let's solve these linear equations. Well, it may seem deceptively simple, but all we need to do here is divide by 5 so that we can get the x by itself. So 5 divided by 5 cancels out to 1. We have x is equal to, and then 0 divided by 5 is 0. Guess what? It's okay for 0 to be a solution. That's perfectly fine. There's nothing wrong with that. Okay? So we're not going to dwell on that. We're going to move over to the next one and say to ourselves, how do I get x by itself? Well, x minus 2, how do I cancel out the negative 2? I'll add 2. such that now the negative and positive 2 cancel out here. We have x is equal to 0 plus 2 is positive 2. Okay. So that means I have my two solutions. My solution set contains those two numbers. So I'm just going to write them out as 0, comma, 2. Those are the two values that could potentially be solutions for this quadratic equation. And that's it. Okay. So you got to remind yourself that it's not always the case that you're going to use the zero product property after using the AC method. Okay. You have four different methods for factoring. Okay. Factoring out the GCF, factoring by grouping. The AC method is only one of them. And then we have the difference of squares factorization. So let's maybe take a look at one more example and leave it there. So let's say that you had this quadratic equation, x squared minus 25 equals 0. Okay, doesn't look like it's in standard form because we don't have the three terms yet again. But if you recognize that this can be factored, then that's the first thing we're going to do. We're going to factor this, but using the difference of squares. If you recognize that x squared is a perfect squared and 25 is a perfect squared. So if you recall from the previous video, to get the factorization here, we needed to sort of take the square root of that, which will just give us x, and take the square root of this, which will give us a 5. So one of our factors is x plus 5. The other factor is x minus 5, just using that difference of squares formula. But this is a quadratic equation, so it should be set equal to 0. And since that's set equal to 0, then we can use the zero product property to split up these factors into their own separate linear equations that we can solve. So x plus 5 equals 0. Can we solve this? Well, all we need to do is subtract 5. Now we have x by itself, and that equals to negative 5. Okay, great. We move over to setting x minus 5 equal to 0. And to solve this equation, we have to add 5 to both sides, cancel out our negative 5 with a positive 5, and we get x is equal to 0 plus 5 is positive 5. Okay, so our solution set can just be written as negative 5, comma, positive 5. Okay, we have our two solutions. Now, you might want to be aware that whenever you have your solutions where they're kind of opposites of each other, one is the positive and one is the negative number, that there is another way that you could write this. So you could write this alternatively as plus or minus 5, where this plus or minus button or symbol just means literally plus or minus, at least that's what we call it. You could think of it as just positive or negative this number, right? So you might read this as positive 5 or negative 5 are your solutions. And so if you see this in the homework platform, this button for a plus or minus, you could make use of that if you don't want to type out negative 5, comma, positive 5. Okay. So there's a little bit to be aware of there. But what I want you to do is make sure you're getting to this homework assignment. It's going to be called Solving Quadratics by Factoring or Using the Zero Product Property. Get your practice. If you need to, brush up on those factoring videos because factoring will be important throughout the rest of the semester. But from here on out, solving quadratic equations is really going to form the foundation for everything to come. Okay, so make sure you're getting your practice in. Make sure you're getting some tutoring if you're running into some trouble, and I will see you guys in the next video.